So following the conveyor belt dual conveyor belt series, our dual conveyor belt, which you have it here, I was asking in part 1 how many inputs and outputs do you have in the system, and many of you delivered me back the number of inputs and output and what they are. So in here we will talk about them. So I'll go with you on all the inputs and outputs for your dual conveyor belt. So here is in the catalog, dual conveyor belt catalog I have. I will go with you over the inputs and outputs names. So in here, let's say I may rotate it. Okay. So here in this photo you see the Workcell system. Here is the Workcell system, in which you can see, starting here, this is the interface PCB. Here you should have your PLC, like it's sitting here. Then starting from here, it's called parts dispenser. So the parts dispenser is here. So you have washer. Here you have height gauge. This is a height gauge. So it measures the height of your washer. Here you're supposed to have width gauge, and this is optional, so we didn't buy it. So we don't have the width with the width gauge. So we cannot measure the width of your washer. Only we can measure the height. So we only have this. We don't have this. Okay, this is we don't have in our conveyor belt. You have here an inductive transducer, so it detects metal. And here you have flippers, parts manipulators or flippers. So maybe plastic, you program it to go this way, and metals to go this way or reversely. And here the parts, it's a reject box. All the parts that are not having the good high, are too small or too big, so then you throw them here. Here you have parts dispenser also, like as this one. It's to dispense parts. Here it dispenses a washer. Here it dispenses the peg. So here you have a peg. Okay. So here you'll be having a peg. So that's a peg. Okay. That's it. That dispense. This dispense the peg. Here dispense the washer. So you have two part dispenser, and these are the flipper. Here you have also, we call them chutes, assembly chutes. And those are the two assembly chutes. Okay, again here you have a flipper. So maybe you take the plastic to one side and the metal to the other side. You have opto sensor here, and this opto sensor is to detect the parts, so you can count them, how many metal and how many plastic do you have. Here is the reject box. Okay, they talk about this reject box for the width. So also this is we don't have in our PLC, so we don't have a width to reject it. So if it's not a good width, it will be rejected here in this box, but we don't have a width gauge assembly. That's basically about the system. So those are the parts for assembly. Metal washer, this is the base peg, plastic washer, and how the peg and the washer will fit. So here are the available height you have. So talking about height or thickness, standard or the correct one is 8. Wrong height is 7 millimeter and 9 millimeter. So it's 1 millimeter difference. So 8 millimeter is a good height. 7 or 9 are a bad height. The parts dispensers, we have one for the pig and the other one for the washer. Okay. And here how it looks like. So here it's the part dispenser for the washer. So you have here an optodetector, sensor. Also you have an inductive sensor in you, and you have the height detector. This is the height detector. Wedge detector, we don't have it. Parts manipulator. So you see, maybe you put metal here and plastic here, etc. Those are the parts manipulators or flippers. We call them flippers. So talking about the top conveyor. Okay, so here is talking to you about your inputs and outputs. So how many input and output do you have? And that was the main question in our case. So how many input and output do you have? So let's see. Here, if you wish, I will start here to PLC input. I will start here to PLC inputs. So means talking about output. So if this is the PLC, and you have here input and here the output, so something they go to the PLC input. Actually they go to the PLC input. What is going to the PLC input? So basically are actually the sensors, right? So here they said they have stop button. Okay. So here you have pin description, and here it is the pin name. Here you have pin name, here the pin description. So you have a pin, the name is stop, and it contains stop button. Okay, so then this is one input you have. You have a height, thickness, gauge button, dead center. Height, gauge, button, dead center. If you wish, height, button, dead center. HBDC, high, bottom, dead center. So this is for the height, for the thickness. You have bottom, dead center, and you have for the high thickness gauge, you have top, dead center. If you wish high, top, dead center, HTDC. That's the pin name. The pin name is HBDC, and the pin description is that's it. So then you have now another input, a third input to the PLC. So you have now three inputs. Stop, pin name is stop, pin name HPDC, HTDC. Alright. You have in addition high thickness. Okay. So high thickness. Okay. It's called high thickness. Okay. Height. It's called as height. This is abbreviation of height. Input 4, etc. So now up to now I have 4 inputs. Stop, push button. Those 3 are for the height. So you have 3 input for the height. HPDC, HDDC, and height. Okay. Okay. Pin name, height. Okay. You have opt1. This is opto pin name opto pre-high gauge opto sensor. That's just the sensor, the opto sensor, which is before the height gauge. Before the height gauge, it's the pre-height gauge opto sensor. They call it opto one. So then I have here 5 input, etc. Then I have another opto sensor, which is inductive detector opto sensor. Okay, we just let's come with the inductive sensor. Inductive detector, they call it inductive detector opto sensor. So you know, so you have another input. You have the inductive sensor. So now up to now I have 7 inputs. Okay, inductive, they call it inductive. What other input you have? 7. Let me move forward. So now I'll take them. Okay, 6, 7. So let me delete them and I move. So I have 7 up to the inductive sensor. If you wish. Okay, 1, 2, 3, 4. All of those are for the high. 5, 6, 7, and you have, we don't have widths. Okay, we have exit guide 1 opto sensor. This they call it opto 6. Okay, in this catalog they call it opto 6. 1, 2, they call it opto 6. Opto 5. So where is opto 3 and 4? We'll look at them. Okay, opto 6 is exit guide 1 opto sensor and exit guide 2 opto sensor. You know, the 2 opto sensor at the end of your second conveyor belt, so to count the number of metallic and plastic parts. So those are them. But also before them you have 2 other opto sensors, so 10 and 11. So you need to make sure that your number of inputs, the input module, PLC input module, can have all those inputs. Otherwise you cannot work on it. You cannot connect all your input in that case. So opto 3 and opto 4 add the shoot opto sensor, first shoot and second shoot opto sensor. So now up to now I have 11. 1, 11 input. So you see you have 11 input. First and second shoot opto sensor. Where are those opto sensor? The third and the fourth. Here for the width diameter, we don't have them, or width. Okay, so exactly you see same as the height. So you have 3 for it, but we don't consider. So now if you have the width sensor, you will use it in the same way. So learn how to use the thickness sensor, then so you can detect any quality like width if you wish later on. And the remaining last one is the start. Start is 12, pin 12. So you have then your PLC should have 12 input. Okay. Yeah, what's this first and second shoot opto sensor? Let's go to the. Okay, so I'm page 23. You want to go to page here, 13. So where are the shoot 1 and the shoot 2? First shoot opto sensor and second shoot opto sensor. So let's now recite our input. So you have star and stop push button are here. If you wish, I will name them as a. So I start by this stop 1, and so you have 3 on the height gauge. You have bottom dead center, bottom dead center, top dead center, and OK. Say OK. So you have, these are 4 inputs to the PLC. Pre-height gauge optosensor. You have here pre-height gauge optosensor, and so this is 5. 6 inductive optosensor. 7 is the inductive sensor. 8 exit guide 1 and 2. So here 8 and 9. Okay. 10, 11 and 12. So 12 is this. Then 10 and 11 are these two. 10 and 11. See, this is the what we call by first and second shoot optosensor. So this is the assembly shoot. When your flippers go this way, then they move this way. Here, this is the optosensor shoot 1 and shoot 2, shoot 10 and 11. Okay, so then those are the 12 inputs you have. So you have 12 inputs in your system. Maybe it's hard to know this exactly. So now when we program it, we'll understand how it works. And do we use all the pins, or we only use 1, or we use 3, etc. So what about the outputs? How many outputs do I have? So as for the output, I will use from PLC output. I look to, so this is the PLC output. So from it to the output field device, how many? So what do I have? Here they call it solenoid 3, 2 and 1. Let's look at them. Solenoid 3, solenoid for the second shoot, solenoid for the first shoot. Okay. Width diameter rejected part. So this is solenoid. We don't have it. We don't have solenoid to reject the diameter, width or the width. HMDRV. HMDRV, it's a motor. It's high motor drive. High motor drive. Okay, they call it this way. So this is the motor that moves the gauge, height gauge sensor. Move it up and down. Okay. Then this is my output 3. So I have solenoid, second solenoid. Okay, they call solenoid 2 and 3. HMDRV. I have dispenser, washer dispenser, which is at the beginning of your. I have top conveyor motor, or they call it conv 1. I have shoot 1 and shoot 2, which is dispenser 1, dispenser first washer shoot, dispenser second washer shoot. So you know the shoot in which you where your plastic goes and your metal goes. So they call it shoot 1 and shoot 2. So 6 output, 7 output. You have exit guide solenoid, so 8 output. You have conveyor 2, 9 output. Dispenser 2, the pig, when you are dispensing the pig, and this is pig, right? And this is the output number 10. So do you have width motor driver? No, because we don't have. So then you have 10 output. So your correct answer will be in this part. The first part of your exercise is 12 input and 10 outputs. But of course, I understand, like for the sensor gauge, maybe you count it as 1. So then instead of 3, you take 1, and therefore you tell me 10 input, 10 output. So if you tell me 10 input, 10 output, I'm considering it right. Okay. Yeah, this is for the part 1 of your lab series 1, real conveyor belt. So this is a roundup in this figure. Here are all your input. You have the start and the stop. You have up to 1. You have height. You have the height. You have HTDC and HPDC. For width you don't have. For width you don't have. just the top dead center and the bottom dead center. Okay. You have inductive sensor, you have up to 2. So I recommend you to name them this way in your program when you program them later. So keep the names of your input this way, so then we directly understand what input you are talking about. So let's standardize them. Okay, start, stop, opt one. So I directly understand that he's talking about opt one, he's talking about this. Okay, opt 3, 4, 5, 5 and 6. Okay, name them this way. For your output, and again, as you can see, you can count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. So this is for the output chain. So also I recommend to name them this way, so then we don't get confused. For the motor, if you wish, for conveyor 1 is this way. It is here. Motor for conveyor 2. Dispenser 1. Dispenser 2. Name them this way. So then you have the driver here. So you control it to turn the height. Okay. Solenoid. So you see, you don't have solenoid 1 then, if you want to name them this way, because this is for the width. So solenoid here and solenoid here. 6, 7. And then you have here this dispenser also, if you wish. They call it sheet 1 and sheet 2. So then it will sheet up to here. So then 7, if you wish, 8, 9. So then this is this linear motor, or this actuator will be activated, and therefore the washer will shoot down in here, and then the pig will come and transport it to here. Okay, that's how the system will work. So we have the assembly in moving it in here. Here it moves without assembly. Here it needs an assembly to move. So because it's going from one stage to another, so you need to have some mechanical trick. And this is it, last output. So those are your outputs in. So name them this way, so we have them standardized.